This is Maths Linear Algebra Tutorial 8, question number 7, the 5a and b. In 5a, this is the original question, and we have introduced a new question 7-5b part. Today we'll do both of them. In this question, we are given a matrix A, and this matrix has been factored into a form PD P minus 1. Basically, matrix A can be diagonalized into three matrices P, D, and P minus 1. Now, then we are asked to use the diagonalization theorem to identify the eigenvalues of A and the eigenspace or the eigenbasis for this matrix. What we know from the diagonalization theorem, it says that if A can be decomposed into P, D, and P minus 1, where D is a diagonal matrix, it must be a diagonal matrix, and that P has an inverse, then we are sure that the elements of D are the eigenvalues and the columns of P are the eigenvectors. So let's find out what they are. This guy is lambda 1, this guy is lambda 2, the last one is lambda 3. And we have V1 here, the second column is V2, and the third column is V3. So let's write it down. The eigenvalues lambda 1 is equals to 5, its corresponding V1 is equals to 1, 1, 1, lambda 2 is 1, corresponding eigenvector is 1, 0, minus 1, and the last one we have lambda 3 is equals to also 1, and V3 is equals to 2 minus 1, 0. So this is the first part, and we have just used the diagonalization theorem identifying P, D, and P minus 1 elements to be the eigenvalues and the eigenvectors. Right. We'll now tackle the second part. Typically, when we can diagonalize a matrix, we wish to do matrix product a to the power of k. Let us put A as P, D, P minus 1. What about A times A? So this is P, D, P minus 1 multiplied by P, D, P minus 1. Remember that we can open up the brackets because matrix products are associative. So P and P minus 1 equals to identity. We are reduced to P, D, D, and P minus 1. D times D can be written as P, D squared, P minus 1, and therefore we can now generalize A times K of them to be equals to P, dk, P minus 1. This is a very nice form because D is a diagonal matrix. We can write it as this way: 5k, 1k, 1k, P minus 1. We will now tackle the second part of this question. Basically, in these questions, we are asked to perform AKX for x equals to V1, the first eigenvector. Basically, we're interested in AK 1, 1, 1, and we want to find out what is the output. We begin with A times V1 is equals to 5 V1. A times A V1 is equals to A times 5 V1, but that means it's equals to 5 times A V1, which is again 5 times 5 V1, which is 5 square V1. Therefore, now we can generalize AK V1 is equals to 5K V1. Now we deal with x equals to V2 plus V3. So we have AK V2 plus V3. Since the system is linear, we can deal with this way. In this case, we can now try A times V2 individually, and we see that for V2, the eigenvalue is 1. So AV2 remains as V2. A times AV2 is the same as AV2, therefore is still V2. So AK times V2 is still V2. Similarly, this can be solved in the same manner. We realize that AKV3, because for lambda 3 is also 1, it is equals to V3. So the solution for this is the answer. AK, whatever k is, V2 plus V3 is equals to the same V2 plus V3. So this concludes 7-5A and 5B. Thank you.